Hi everyone and welcome back to the next lesson of our Java course. So in last program or the video, we created a simple Java hello world program, right? And we just run the program to see the output. So in this lesson, I'm gonna focus on what was the different components that were under the hood that get into the picture and help us to create that program and also run that program, right? So again, we're gonna look into some of the different perspectives of how the Java ecosystem works, right? Okay, and you might have seen this terminologies about Java. It's basically you write once and then run everywhere. What it means is you write your program, and if this program is as per the language, then you can run it on any program. So you might have written your program into Windows, but then you can run the same program in the, let's say, Linux or in a Mac machine or in a Android or in any of the environment which basically support Java, right? So there is no magic out of it, right? It's basically a clever engineering. So, and we're gonna understand all these different details, how these different things comes together and then make it a platform independent language. That is one of the strong feature of the Java, right? So what we're gonna do is what happens when we compile our program. So there are certain things which Java is doing for us. So we're gonna take a peek into that. What happens when we compile our program? How Java will make sure that the program can be run onto the different devices. That's what I talked earlier, right? It's basically a platform independent feature, which is as I said, right? It's one of the fundamental or the powerful feature of the Java. And then we're also gonna talk about what are the different tools which we need in order to develop our Java program. All right. Okay. So I'm just gonna talk about the big picture. So think of your Java program as a recipe, right? You basically create a recipe. So you probably have your own recipe. I probably have my own recipe. And then there will be, it's kind of a source code, right, that we write. For example, in the last one, we write our hello world program. That was just a recipe. Then we need a medium, or we need a way where we can translate these different type of a recipe. So you might have used your own language, terminologies and other things. I might have used my own terms, my own things in order to create that recipe, right? But then if everyone is writing their own type of recipes, how I will understand yours one and how you're going to understand mine one, right? So we need some sort of a common language which we can use in order to understand that one. So that's where our compilers get into the pictures. So they basically make sure that your recipe, which is in our case is the Java program, that should be translated into a common language which the computers understand, right? And then finally we have the JVM. So JVM is nothing but, think of JVM as your kitchen, where you have all the things, all the everything, which then you can basically, based upon that recipe and the things that has been translated, I can run that program. All right. So that's how the overall things look like. If you see into the pictures, you write a program, a simple program. It could be a simple program as good as hello world, and it could be any complicated program where you might be creating an enterprise software, or there are some program which create the programs for space, right? You write a program, and then we have the compiler which gets into the picture. So compiler takes your code. It basically makes sure that your code adheres to all the language rules. If everything looks good, it converts that code using a compiling process to convert into a machine understanding format, which is a bytecode. All right. And then finally that bytecode is run by the JVM. All right. So as I said, there are three components. I'm going to talk about all three of them. So the number one, or the core component, is the JDK, which is nothing but a Java development kit. All right. So think of it as your a complete kitchen, right? Where you can basically have all the tools, everything to prepare your or to follow your recipe. Or think of it as so when you are building a house, right? So Java program is nothing but you are basically building a house. So you need the tools, you need the materials, maybe a construction site where you want to build your house, right? So in Java, the JDK is like your toolbox. It contains everything. So it has all the tools, everything in order for you to build your house, which means in order to write your program, to compile that program and to run that program. So it's the complete ecosystem itself, right? Okay, so I'm going to touch base a little bit about the different components of the Java. So number one is the compiler, right? This is one of the core component of your JDK toolkit. All right. So the main responsibility of your compiler is to convert the .java class into the bytecode. So if you remember from our previous lesson, all Java classes are saved as .java, right? That's the extension for your Java classes, right? So the compiler will make sure, number one, it basically validate your code, making sure it basically follow all the rules of the language. And if there is a problem, it will tell you upfront before it converts that file. And then it will ask you to correct it. So that's number one. Number two, it will make sure that, okay, there are no issues, nothing. If everything works fine, it converts that file into the bytecode. Bytecode is nothing but something which computers understand. So after the compilation process is done, your code or the file which is created by the compiler ends with an extension, say .class file, and we're gonna look into that one, right? Then we have the JVM, which is a Java virtual machine, right? So once your code is compiled, the JVM basically takes over from there to run your program. So JVM responsibility is to make sure the program can be run onto the different environment. It doesn't matter, the same file can be run onto platform A, which is, let's say, maybe on Windows, and then maybe the same program running onto the Mac system. All right. And finally, some of the libraries and tools. So in order to write your program, there are certain pre-built libraries or the code that is also available for you as part of the JDK. So, and these libraries or these codes help us to kind of perform common tasks, right? For example, how we handle the files, write the files, read the files, our networks, how we communicate over to the networks, right? And few other things. User interface is one of them, and some of the main things. All right. Okay, so before we dive into the next part of it, I'm quickly gonna talk about the compilation process, because I believe this is one of the fundamental concepts we should understand, how the different steps get into the picture, right? So I'm quickly gonna go to the our IntelliJ, and we're gonna start there, and then we'll. All right. So in last video, I think what we did is we wrote this program, and then we used this run command or the icon to run our program. So there were a lot of things that was done automatically by the IntelliJ. So we are not able to kind of get into the details how these different things work. But now what I'm gonna do is I'm gonna use the actual command, which normally even the IntelliJ and other editor will are gonna do in the backend for us, is the compile, right? So first step is the compile. So what is going to happen is I'm going to use the javac, which is the compile command, and then I'm going to tell what is the file name. So as I said, all Java files ends with .java extension. So when I'm going to compile this one, all right, what it's going to do is it's going to create a class file for me. So if you see, this is a class file, right? So the class file is nothing, but it basically contains your compiled program, so which is a bytecode representation. So when we write our Java source code, it is compiled into the dot class file, right? It's the first step. Every program is gonna go through this step, so there is no exception into that, right? So, and again, So the java.class file contains nothing but what we talked about is the bytecode, which is a platform independent representation of your code, the code or the language which a computers understand, right? All right. And from their perspective, it's basically nothing but a code or the language which JVMs understand it. Okay. Now the question is, do we know what exactly is there into this file? So if I double click on this in editor, it's gonna decompile for me, and you will probably see the same result, right? What you have seen, because these editors and these decompilers are smart enough to tell you, okay, what exactly have you written. But there might be a few tweaks, right? But this is not the actual the bytecode that was created as part of the your compilation process. So if you are really interested to see what the bytecode will look like, you can use another command which says java p, and then I'm gonna hyphen c, and I'm gonna say hello world dot, and you don't have to write dot class, because class is nothing but your source code. So I'm gonna write this time is dot class file. All right. So this is actually the bytecode that was created by the compiler. So if I go outside of this editor, this class file contains this data. So you see there are a lot of things going on. So that's the bytecode representation which your JVM understands. All right. And if your question is, or if we want to go a little bit deeper in terms of what is the relation between a class file and the bytecode, right? So think of .class file essentially as a container of a Java bytecode. Okay. It also includes a certain other things, certain metadata, such as information about the class, for example, the name, right? This is the name, and if there is any parent class or any implementation interface and other sort of things, that's part of your metadata, right? Then it also contains information about the methods and other things. We're going to talk about that, but if you remember from our previous video, this is the main method, right? So it has that information about that, right? Then it also have information about the constant pool, and I'm not going to talk about those things, and then annotations, attributes, and other things. But in short, class file contains, or it's sort of a jar where all the bytecode information is there. All right. Okay. All right. So we talked about the JDK. So this is the overall architecture of the JDK look like. So you see all the different things are part of your JDK ecosystem. So your JDK ecosystem is sort of umbrella, a big umbrella. Your JRE is part of it. Your JVM is also a part of it. And there are other things we talked about, right? Some of the libraries which are provided for us in order to ease our efforts to write the program, some other developer tools and other sort of things. All right. So next, what I'm going to talk about is the JVMs, right? And there are quite a few things about the JVM. So again, as I said, right, the real hero for write once, run everywhere is the JVM. Okay. So it basically translates bytecode into a machine code, so which the machine can understand, right? So the main responsibility of the JVM is to make sure keep it as a platform independent, where you don't have to worry about whether my program is gonna run on, let's say, on Windows. Is it gonna run onto the Mac? That's something which these things are gonna handle for you, right? Okay, so what exactly the JVM is gonna do for us? So as I said, it loads the bytecode. So it reads the class file containing like all the data, and then it loads the bytecode information, right? What we have seen in our in our previous thing. Then it basically interprets, or it understands that bytecode. So JVM either interprets the bytecode line by line, means it goes through each of those bytecodes one at a time and try to understand what has been written, what needs to be done exactly, right? Or there are some it's called as a just-in-time compiler. And don't worry about it. We will gonna cover those one, but these are some of the tools and mechanism by which it basically reads the bytecode information, and then it makes sure it's able to run those information and give you the desired output, right? And then JVM also manage the resources for us, right? Which means memory, garbage collections, and few other things. We'll gonna touch base during this program, but there are a lot of other things which is going for us. One of other thing which if you're coming out from, let's say, from C or C++, one of the another strong feature of Java is the memory management. You don't have to write any specific code to do the memory management, because Java is gonna take care of those, and JVM is the one which takes care of it. So which means it allocates the memory. It also makes sure that the memory is being free automatically, so our program has the sufficient information. So all these things run behind the scene, and JVM is something which is kind of taking care of those ones. The JVMs are sort of a platform specific. Okay, and that's where the pictures come into. That's where the entire things get into the pictures, right? So JVM act as a bridge between your platform independent bytecode. So the bytecode that has been created, right? It doesn't matter if you compile your program on Windows or onto the Linux or onto the Mac OS or any other platform, right? The bytecode representation is gonna remain same. That was basically the class file. Okay, so think of JVM as a bridge between your platform independent bytecode and the platform dependent machine code. So when the code runs onto a certain machines, right, this has to be translated into the underlying machines, because the file system, for let's say if you want to read a file, the file system in a Mac OS or into the Linux is entirely different than a Windows system, right? So that will not work if you have the same sort of JVM, right? Because how we read the file, how the directory structure is, what are the different things that can handled onto the Linux for a file is entirely different than Windows. Or how we basically do the networking calls or network calls into a Linux system is totally different than a Windows machine or a Mac OS. All right. So each JVM is built specifically for a operating system and the hardware architecture that runs on it. And when you install your JDK, you might have seen, okay, this JDK is for this, maybe for Windows, maybe for Linux, maybe for XYG platform, right? So as I said, right, a JVM for a window probably convert the bytecode into a Windows specific machine code. Another JVM for a Linux machine might convert the bytecode into a Linux compatible machine code. All right, so we talked about the JVM. I think the next critical component is the JREs. So JRE, if you see here, right, JVM is a part of the JRE. So JRE is a Java runtime environment. This is the minimum you need in order to run your program. I'm not talking about executing your program or writing your program. I'm talking about running your program. So let's say you have created a program. You have write a program which, let's say, calculating mortgage for a customer, right? And now you want to deploy that program so that customer can use that. So all you need is a JRE environment to run your program. All right. So your compiler is gonna do the compilation for you, which is the .class file, and then the JVM is gonna or the JRE is gonna take care of this one. So JRE, again, I said, is a package of JVM and the JRE. So JVM is gonna do few things for us. For example, it's gonna it's gonna read that bytecode and convert it into a machine specific code, right? That's part of the JVM. But then JRE has that part, and then it needs few more things. For example, it has all the configuration, some other bootstrapping and other things, right? So JVM is sort of an engine that runs the bytecode, and the JRE is sort of a full package, right, which combines the JVM and few other libraries to kind of which is needed for our program to work. Okay, so if if you call JVM as, let's say, a car engine, then JRE is the entire car in itself, right? Which means it has wheel, it has fuel, it has everything else to get it going. All right. So just to summarize it, I think the JRE I would call is as an environment that makes running of a Java program possible. So it includes JVMs, libraries, something else, which is actually needed in order to run your program. So I'm to put it all together, what we have learned so far, right? I think there are a few things which we gonna do. So we gonna write a program which is .java class, right? Then the JDK compiler is gonna compile it and create a bytecode, which is nothing but a .class file. All right. Then our JVM is something which gonna read that bytecode, gonna load it into the JRE, right? It's gonna convert it into a machine specific code. All right, so it basically takes away that platform independence things. And then finally the JRE is something which gonna cover both JVM and the JRE capability and run the program. And finally I'm gonna see that output on my screen. So when you run that hello world program, right, we wrote that program, we click onto the run, and we saw the hello world as the final output. So now, so with this one, I hope that you get an understanding. When we wrote our program hello world, right, there were a couple of things which were working under the hood. So now we should have a clear understanding what all it takes in order to run that program. All right, I hope this will give you some basic understanding of how the Java ecosystem works, how the compilers, JVMs and JREs works together in order to run the programs. Again, if you like the program, if you like this video, please don't forget to subscribe, and if you can share the channel with others, that will be really good. Once again, thanks for watching this lesson.